Hey guys, this is Om and welcome to Civil Raja, your gateway to future. So guys, in today's session, we will start with the basic modeling in STAAD Pro so that you can have a clear idea of how the STAAD Pro works. So after this basic modeling, we will also go for a live project, but I am just starting my session with the basic so that you can have a clear idea about how we have to proceed with the steps in a STAAD Pro. So first of all, we must understand that the modeling takes a lot of time, so I am just going to skip that modeling part in this particular session, and so for that I will go for the basic modeling. Okay, and I will also tell you what will be the difference when we are working on the live project. So pay attention to this session because this may be a little longer than the previous sessions, but it will be worth learning, or you can say worth watching. So first of all, this is our STAAD Pro interface, and here you can see many options are there. First one is the open. So in open we have different categories. The first one is recent. So here are my recent projects that I have covered, and you can see you have may have a glimpse of the all my projects and the frames that you can see over here. If you want to just check out the project details, you can just hover over any project, and then you can see on the right side we have our project details over here at this corner. Now I will start with a new one. So just click on the new project. Here you can just name your structure. So basically this is a like basic modeling, so I will just write it as a dummy project. Okay, dummy project 1. Okay, let's write it this one. Then we need to locate the file, and for that we will have to choose the location. So I will just go to the browse section, and over here I will create a folder where we have to just keep all the files. So this is all the project that I keep over here, and over here I will create a new folder. So you have to always keep your files in a particular folder. So you can see I will name it as a project. What was my last project that I will check? So this is project 35 that I have originally had. So I will just name it as project 36 STAAD class. Okay, let's say I will name it as this one, STAAD class. Then what we will have to do, we will have to simply select this project 36 STAAD class, and I will just click on select folder, and my folder will be selected over here. Then there are three types of modeling that you can see as analytical modeling, physical modeling, buildings, and here you have our units. Either you want to use your English units, that is feet and inches, or you want to go for the metric units. So always go for the metric units because all our IS code is modified according to the metric unit, but in the foreign codes such as the BS codes we use the English units. However, here we will go for the metric unit only. After that, if you want to change the units, then you can like change the units in your results, but in STAAD Pro try to keep it as metric unit. Then you can see we have our job info. So in the job info you can just name your jobs like whatever your project is. So I will write it as let's say project 36. Okay, project 36 dummy project, or a STAAD class, whatever you want, you can simply name it as that one. Okay, now if you want to just name a client, so you can write the name of the client over here. Let's say I will just XYZ over here, the project number I will enter it as 36. So whatever is your project number, you can simply write it like that. Okay, now it is a revision, so I don't want to I have not revised this one, so I will not change the revision. So I can just skip this portion, and then you can name your engineer, like whoever engineer is working on you. So if you will work over here, simply write your name. I am working on this one, so I will write my name. Okay, so here you have to mention your name because you are the engineer of the project, and then there is a checker, there is a approver. So these comes later. Okay, so in the checker, first your design will be finalized, will be you, then it will go to some IIT. If it is going for the waiting, then he will be the checker and approver. Okay, now the project date that you have to mention. So today we have 27th of the June, so we will just go for 27th June. And if you want to write any comment about the project, then you can simply write it over here. If you want to just leave it, you can simply leave it like that. Okay, then these are the project things. If you want to make some kind of configurations, then you can also click on the configured, and this is basically acting as a settings of your project. So whatever is your setting, you can simply write it like that, like your base unit is metric over here, okay, or English over here, what is your base unit, you can simply change according to that. Then you can, if you want to change the language, you can change the language, but by default there is English, and options are only provided as English over there. If you want to change the background color, you can go for the color of the themes and the background. You can simply change it from here, but I don't want to go for any particular thing, so I will simply keep it as default. Then we have this our option of display. Okay, so if you want to display the license option or not, so just keep it like this. One if analysis performed across network. Okay, so you can just keep all the settings as it is. Okay, you don't need to choose anything. Now single format commands, if you want to just go for the member format, then you can just go for member format, or if you want to change it, then you can just simply change it. Then the joint coordinate significant figures, how many figures you want over there, that means the digits. Okay, then you can simply change the digits if you want. Okay, log maximum errors per single input as 10, log maximum errors as 100. Okay, so you can simply just keep it like this, that is not an issue. Okay, I will simply show you how to do work with the configuration. Okay, that is the most important part of whenever we are starting with the STAAD Pro. You can simply change the configurations accordingly. I have not saved it, so I will just change the base unit to metric unit. Options, I have to keep it like this. File formats, okay, I don't need to change anything over there. For steel, I always have to use the steel code as IS 800, so I will simply choose IS 800. Then also you have to options of like IS 800 2007 for LSD, like a limited state method, and then for the working stress method you also have the option, but I need IS 800, so I will simply keep it like that. Then for this one I will use IS 456 for our concrete. We all know that the concrete is IS 456. Aluminum we do not use, the timber we do not use, so you can simply keep it like that. Okay, that is not an issue. We can simply keep all this as default. Okay, then the section database is there. So whatever is your section database, you can simply just go ahead and change it according to your requirement. Okay, like for the India, we have the Indian sections. Okay, then we have the option of the confined steel joints, aluminum. Okay, so these things are available over here, but we do not need to like do anything of changes over here. However, if you will go for the advanced work, it will not be needed by you, but there is an option that if someone is working on foreign environment, then they can also custom the profiles according to their need. Then comes the workflows. So over here we have different workflows that are accessible to this one, like our building planner and the piping are connected with this one. Then the foundation design, steel auto drafter, okay, channel steel design. So if you don't need the channel steel design, you don't want it, then you can simply do unselect it. Okay, then the connection design. Then after that we have the advanced concrete option, advanced slab design. So if you want to use all this, then you can simply use this. Otherwise there is RCDC that you can use. Okay, that is not an issue. Then whenever you think that you want to go with the default settings, then you can always reset settings. Now click on OK. Okay, so you have already configured everything over here. So just to check the configuration, you can simply click over here and you can see I have changed the unit of the to metric, so I have got the metric unit over here. Then comes the license. You do not need to mess up with the license, you have already cracked your software, so you simply keep it like that. Then the archives, share, help, these things you can just go ahead and check it, but this will not be of your use since you are not willing to share the files with anyone else, so you can keep it like this one. Okay, so I have already filled all my job information, everything over here. Okay, the model info is also placed. Then I will click on create over here. Okay, and my new file will be created. Okay, so since I have already unchecked the Chinese steel design, so it is not showing over here. If you want to uncheck anything else like the earthquake or advanced lab design, you can go ahead and uncheck these things, and that will just make it shorter and more accurate or precise according to your requirement. But I do not have any problem with the presence of these things, so I will simply leave it like this. Now if you want to add some coordinate, then you will have to enter your coordinates over here. Like once you are done with the building planning, then you will have to just create the beam column layout, and after that you will have to bring up some coordinates. I think you already know all these things, like how to make the coordinates. If not, then please let me know. I will just make a video on that one also. Or I have already covered the marking of the coordinates in the previous session, so I will add a video to your recorded session. Okay, that's not an issue. Now, once you have your coordinates, you can simply enter the coordinates over here. You must need to know that your software opens in such a way that y is up. Okay, if you want to make the z up, then you can also go for the z up. That is not an issue. But I am like very much practiced with y up, and this is the default one. So we always keep the y up over here. So just keep it like this, y up, and then x and z planes are x and z coordinates makes the x z plane, and that is our horizontal plane. Y is our vertical plane. Okay, so basically, no, sorry, y is our vertical axis, and xy and xyz are our vertical planes. Okay, I think this is clear. Now I want to enter the coordinates over here, so I can simply enter it like this. So I will have to enter the coordinates, so let's keep it as 4. Okay, and if you want to know what is the conversion unit, so whenever you multiply your meters to 3.28, it converts to feet. Okay, so that's why if you simply divide this with 3.28, it will come to meters. Okay, so feet divided by 3.28 comes to meter. So let's say I'm just going with a 10 feet by 10 feet block, so I will simply use the 3 meters option over here. Okay, so I will keep the x as this one. Y I will keep it as 0 because I want to work on the 0 plane, that is xz plane. Then z I will keep 0. After that I will make another 1/3 over here. Okay, then let's keep this one 3, and then this 3, and also this 3. Okay, so I have 4 coordinates that you can easily see over here, right? So you can go to the view option. Earlier we were in the geometry option. In the geometry options, we have always different things like the beam grids, the triangular grids, the solid groups. So these are the things that are available over here. If you want to use the grids, then you can also use the grids. If you want to use the structural wizard, then you can also use that one. Okay, but that is very much useful for the trusses. Okay, basically the frame models. If you want to go for the frame models, you can always create a bay frame over here. Okay, you can simply undo all these steps and you can go for the bay frames. But let's that we do not use in our live projects, so I will simply just skip it. Okay, and then we have the option of the saved user model also. If you have saved anything, I haven't saved anything, so I will not use it from here. Okay, now let's close this one. So that was about the grid and the structural wizard. Now whenever you think that these things are not highlighted, simply click on this plane area, that is the work area, and you can simply use all these commands like the translational repeat, which is very much useful for us. Then we have another option as a circular repeat. I haven't used it yet, but I think whenever I will have a work of designing the circular staircase, then I will have to use that. Then there is our geometric rotate. Then we have our slab and wall connections. Then we have our mirror. So after that we have our input units. Okay, so whatever input unit you want to choose, you can simply choose it from here. Like in the metric units, we have the input unit as the millimeters. Okay, and in the force we have the input unit as the kilonewtons. Okay, that we normally go for. Okay, so over here, if you want to work in the mms, then you can simply choose millimeters, and then for the force you can choose kilonewton. Okay, like millimeters you can apply. Okay, but that is something we do not normally use, so we will keep it as meters. Okay, so wherever whatever is required, we can simply change accordingly. But for now we will have to go for the view, and in the view options we have a lot of things that you can see over here, like label settings. If you want to choose some labels, then you can simply choose it from here, and these labels are very much useful. But how it is useful, that I will explain you in whenever it is required. That's how you will have a better idea of all these things. So these label settings will be useful for you, basically. That is the thing. Okay, then if you want to just simply change the node labels, or if you want to change the beam labels, okay, so you can simply hover it from here, individual node labels if you want to change. Then the plate label is there. then we have solid levels, and then we have plate levels and individual solid levels. Okay, individual plate levels and individual solid levels are also there. So if you want to choose, you can simply choose it from there. Like if you will click on the node levels, you can simply see that okay, the node numbers are clearly visible over here. The first node is this one and the second node is this one. Okay, so you can simply change it, check it from here. If you want to undo it, you can simply just undo it. Otherwise, other than that, if you want to check the levels of the nodes and if you want to see the node numbers, then you can also press Ctrl+N. Okay. Okay. Sorry, I will just go for this. Yeah, sorry, not Ctrl+N. Ctrl+N will open a new like a work area for you. So you have to go for Shift+N. Shift+N will show you the node numbers, and Shift, if you will again press Shift+N, you will see that the node numbers are gone. Same thing you can do with this icon. Just go to the view and then you have the node levels. You have to click over there and node numbers will be visible. After that, click again and node numbers will be gone with you. Now along with that, we have this zoom window option. Like suppose you have to zoom at any particular area, then you can simply use this one, but not now. We do not have to use this one now. I think you have already used this zoom window option in your SketchUp or AutoCAD, whatever you use for the drafting software. I personally prefer the AutoCAD. Now comes the display whole structure. Once the whole structure is visual, then you will have a very much use of this one. Then you have this zooming option, zoom in, and then zoom extents is there. Okay, like if you click on the zoom extent, suppose you have zoomed in like this and you will click on the zoom extent, it will completely fill your screen with this zooming option. Okay, so zoom extent works that much. If you want to like zoom it like so, let's say I have zoomed out like this and I want to click on zoom window and I will select this much area, so it will be zoomed accordingly. Okay, now then there is an option of dynamic zoom. Okay, so you can see this dynamic zoom is working. Then there is an option of zoom in, so you can simply just click on the zoom in like this. Okay, then the dynamic zoom is working like this. Let's cut it. Okay, then we have this another option of magnifying glass. So if you want to use your magnifying glass to see anything precisely, then you can also use that. Then we have the option of zoom factor. If you want to like zoom it for a particular factor, let's say I am going for 0.5 factor, then it will zoom out like this. Okay, same again if I want to use another zoom factor as let's say 2, then it will be zoomed a lot. And if something like this happens ever, then what you can do, I will simply first turn off the magnifying glass over here. Okay, so that I can bring my cursor back. If something like this happens, then you can always go for this option, that is zoom extent. Click on this one and it will bring all your model, the complete model, in a single frame. Okay, so you can simply check it from there. So that's how zoom extent is useful. Display whole structure and zoom window. This zoom window is not very much useful, but for us, like I don't need to use that one. Then there is an option of the zoom previous, like whatever it was the last zoom that you have done, you can simply go back to that like this. And then we have the option of the pan. If you want to drag your screen like this, left to right or top to bottom, it will be working in a way like you have hold a plain paper on a table and then you want to slide it with your hand, then this something like this will happen. Okay, and this is what is the use of the zoom pan. Okay, now whenever you are into a command and you want to come out of that one, then simply press the escape button, ESC button on the top left corner of your keyboard, and you can just come out of that command and your beam cursor will be here. Okay, or simply say cursor will be here. Okay, then we have these options. These options are very much useful. Isometric view, like right now we are in the isometric view. If you click on this one, it will be the isometric view. If you want to work on the top view, then you have to simply click on the top view. So you can see I have the top view option over here. Now instead of using from the pan from here, you can simply like press your wheel button on your mouse and you can highlight your pan option. Now you can see I have my pan option over here. Now if you want to add the beams, then you can simply go to the geometry, and there you will have option of add beams. Okay, so you can simply add the beams from here. But what I prefer, I like I want to come out of the command, I will press the escape button. What I use is I will simply right click over there and then click on the add beam options, because it is a very tiring to go back to the geometry every time and click on the add beam. So this is what I prefer, just right click and go for the add beam option, and your add beam will be highlighted or checked, and then you can simply add the beams from here to here. Now in adding the beams, there is something that you need to follow. There is a very basic thumb rule. It's not like it is a mandatory thing, but if you will just go with this one, then the precision of your modeling will be high. Okay, so see so yeah, so whenever you have to go for the addition of the horizontal beams, just go from left to right. Okay, and whenever you have to add the vertical beams, go for bottom to top. So left to right and bottom to top. This is the way that you have to follow when you have to work on this one. Now if you want to select the beams, then you have to simply press the like escape button, and you will come out of the command. Otherwise from here you can also go for the selection of the cursor. So basically this cursor is our beam cursor. Okay, if you want to select the beams, it is good to go. If you want to select the nodes, it will not be selecting the nodes. So if you want to switch the cursor, you can just go to the select cursor option, and there from there you can simply select the nodes. Okay, so whenever you will click on a node, then it will be selected. And if you want to select all the nodes at once, or even a set of nodes, then what you can do, just press the control button and simply drag it like this, and you can see this node as well as this node is selected over here. Okay, if you want to select all the nodes, you can simply select it like this. Okay, simply press and drag. Okay, now if you want to switch to some other cursor like the plate cursor or the solid cursor, you can simply come over here, but it is no point of selecting such cursors because we haven't created any kind of plate on this. Okay, so what I will do, I will simply press the escape button to come out of this command and go to switching, simply select beam option, or I will simply come to the select cursor and then choose the beam cursor. Okay, now that I have chosen my beam cursor, so what I'm going to do, I will tell you how to use the translational repeat. And one more thing, whenever you will select the beam over here, you can see that on the right side our beam desired beam is selected. Also this works in the reverse way. Suppose you want to like select beam number 3, click over here, and your beam number 3 will be selected in the display option or the work area. If you want to go for the beam number 4, you can simply select it from here, and this will be very much useful whenever you are working on like making your model work free, or sorry, warning free or error free. Okay, so this will be this trick will be helpful to you whenever you are going for the selection of any particular beam, because in the warnings or the errors you will get that okay, this particular beam is failing, this particular beam is are not good enough to accommodate your reinforcement. So warnings like that will be showing. Okay, so you can simply select it from there. Also, if you want to select a particular node, you can simply click on the node and you can say I have clicked on the node 4, and the node number 4 is selected over here, node number 3 is selected like this. Okay, if you want to choose both of them, you can simply drag it like this, and both the nodes you can see it has been highlighted in the red color. Okay, so these are the few options that we have to use. If you want to simply use a magnifying glass to see the highlighted one, then you can see this is simply selected, so this is in red. The node number 4 is selected, so this is in red. Node number 2 and 3 2 and 1 are not selected, so this is in black. So unchecked nodes are in black and checked nodes are in, or you can say the selected nodes are in red color. Okay, so this is how the software works. Now I will simply come out of this command. Now I want to use the translational repeat. So for that, I'll have to go to geometry. I will simply select all the beams. Okay, so for the selection, you need to understand, I am explaining everything in detail over here in the basic modeling series, so because in this basic modeling video basically. So because whenever I will work on the live project, I do not want to waste my time on all the concepts over there. So pay attention to this one. If you will just understand all the things that I'm explaining over here, it will be very useful to work on the live project. Okay, and if and if after the class you are finding any difficulty in understanding any particular concept that I have like shown over here, then you can simply text me on the WhatsApp. You already have my number. My number is 84332488864 that you can see on the screen, and you can then just connect over this. Okay. Since you have already joined our paid class, it is like very much useful for you. Now comes the next thing, that is selection. So basically this works in the same way as the AutoCAD. If you will just drag something from right to left, it will select everything that is coming inside this particular box. Okay, if you have selected something, you will click at some other place randomly, then the selection will be gone. If you have selected something and you are pressing Control, then you are clicking somewhere else, the selection will stay with you. Also, it will add up something to your selection. Okay, so this is how the selection works. The next thing that will be very useful for you when we are working in the top view, that whenever you are dragging something from right to left, then whatever this box is touching, this dotted box that you can see over here, whatever this box is touching, everything will be selected for you. Okay, got it? Now we will go over here, and first of all we will save this model, because saving the model every now and then is very much useful for you. Otherwise, if somehow your model is closed, then you may lose your work. Okay, and your time will be wasted. Okay, so now you can see over here, I have told you that there are basically 3 axes over here. First one is x-axis that you can see, which is left to right over here. Z-axis top to bottom, y-axis is vertically upwards. Okay, so in the z-axis, if I want to make some repetitions, then I can simply go for the repetitions. Okay, and now since I have selected 3 meters, okay, so I will just keep it as 3. Okay, and if I will click over here, it will be automatically choosing 3 over here. Okay, now let's start everything with the basics. So I will just keep generation flag as all. Okay, if you want to just go with the geometry only, you can just go with the geometry only also. Right now I have not inserted any kind of property, so that is not an issue. Like if you want to like copy the properties also, then you can go ahead like that. Now if I want to select this one and I want to go for the translational repeat, and I'm not checking the link steps, then what will happen? Let's see. So I'm just making 3 over here. Okay, click over here, and the spacing will be automatically changing to 3. So I have not changed it to link steps. Okay, and I'm keeping it all over here. That is not an issue because I have not inserted any property. So either you go for geometry only or you go for all. So that will not be any kind of variation in your structure. Now and these options are also useful. Okay, once we will start working on the live project, you will see that these options are also coming into your use. Now I'm not clicking on the link step over here. Okay, so let's see this example first. Click on OK, and this thing will be copied over here at a distance of 3 meters. Okay, now I will go to my add beam option. Okay, so just right click and click on the add beam, and whenever we have to go for the horizontal connections, we go from left to right, just like this. Okay, now I will bring it back to the select beam option. Okay, by pressing the escape button, then I am selecting this one. Again I am going for the translational repeat, and this time I am keeping the distance same, but now I am clicking on link step over here. Now whenever I will click on the link step, earlier only this beam was connecting over there, but now this beam will be this beam was copied earlier. This beam will be copied, but the 2 dots that are present over here will be connected to the next dots that are present over here in the same direction. Okay, so click on OK, and you can see I am getting the same thing at a same distance. Okay, so I hope this thing is clear with you. Now if I want to go for the multiple repetitions, then I can also go for that. Like suppose I have selected this one, I want to go for the translational repeat. Okay, so since I don't want to create any negative things, negative data, so I can simply choose the bottom one. Okay, if you want to go for the negative data also, then you can simply select this one. I will just show you if what will happen if you go in this direction. Suppose you want to click on Z axis and you want to move in this direction and top direction. So I told you that from top to bottom is our positive Z axis. So I will go for -3, and let's say I am going for single one. Okay, because I'm going to undo it, so I will just go for single one, and I'm just I'm not checking the link step over here. Okay, so you can see this is copied at a distance of that. Now over here we can see these are the negative points. Okay, so if I can use it over here. Okay, so these are the negative points that you can see. These all nodes are negative points. Now I don't want to do this, so I will simply press the Ctrl Z and all my beam will be gone. Now I told you that from top to bottom is our positive axis, so I will simply select this one, go for geometry, then translation repeat, go for the Z axis. Here I will mark it as 3, then link steps, and now this time I am increasing the number of steps to 3. Okay, now click on OK, and you can see this is making 3 more copies. That means 3 more steps over here, and all the points are linked over here. Okay, now if I am selecting the whole thing, I am switching to isometric view, then come to the geometry option. Okay, and here I have the translation repeat option. I want to make something in y-axis, so I will simply, let's say, keep the height as 3 meters. Okay, and instead of 1 I will try to make it 4. Okay, so it will be repeated 4 number of times, and this time I want to link the steps, so click on OK, and you can see the grid like this has been created. Now again I want to create a grid at the bottom, but this time I do not want to copy the beams. Okay, so what I will do, I will go to the view option and then front view. I will switch my cursor to nodes cursor. I will select this one. Okay, then I will go back to the geometry, translation repeat. So again I told you that we have used it to repeat, or you can say view isometric. Okay, so earlier we have used it to copy the beams. Now this can be used to copy the nodes also, and if you want to link steps, then you can also go for the linking the steps. So I am giving it a distance of 1.5 meter. Okay, that means around 5 feet, and then I will simply click on link steps and click on OK. Okay, so what happened over here? Control Z. We made some error. Okay, what we did, we did not put the negative sign over there, so it backfired at us. But we will simply just go for the translation repeat, and whenever we want to draw something in the bottom, and since here the vertically upward direction is the positive y-axis, so we will go for a repetition of 1.5 meter, and the steps will be 1 only, and then we will click on the link steps and click on OK, and you can see we have created the points just beneath every point at a distance of 1.5 meter. Okay, I hope this is clear with you. So modeling is something that we have already completed. Now click on the view option. Okay, then over here we have our different options of the rotations, but rotation is something that we can do easily by just like click over here, and we can use our 4 arrow keys. Arrow keys, that means the upward key, the downward key. Okay, so you have to simply, you can use all those arrow keys to rotate this, so that is much easier to use. So do not go for this option of rotation up or rotation down or something like that. Okay, you do not need to do all these things. Then come to the isometric view, and we have got our isometric view. Now next is spin left. Okay, and it has been spinned to the left. Spin right, it has been spinned to the right. Okay, now come back to the same point, then we have this option of fit in circular window, which we do not need. Orientation, whatever is your orientation, you can simply just go with the orientation, like you want to work in the isometric view or you want to work in the perspective view. Suppose you want to work in the perspective view, then it will show you the perspective view, the view that you have seen earlier. Okay, so right now we want to work in the isometric view only. Okay, and whatever is the view, you can simply change the views from here. That is not an option and not a problem. Okay, I like to work in the isometric view, so I will click on the isometric view from here. Then comes the selected objects. Okay, whatever like suppose I have selected these objects, okay, and I want to work on these objects, and suppose I want to change the properties of these objects, then I can simply click on the selected objects and only these objects will be visible to me. I can simply check on the properties. I can check their geometry, property, loading. If I want to change it, then I can also change it. I want to assign any kind of property over here or any kind of load, so it is not visible. Now selected objects are very much useful for you. Okay, then there is an option of view management, where you want to, if you want to save the view, then you can also save it from here. Now I told you earlier that this option display whole structure is very much useful. So selected option works side by side whenever we have to make the changes in the like properties of our model. So click on the display view whole structure, and the whole structure will be visible to you clearly. Now if you want to change some display options, then you can also go ahead and click on that and you can change the display options. I like to keep it default. Then the structural color, if you want to change it, then you can also do that. It will give you a vibe of working in the Tekla. Okay, so over there we have different colors for different things. Okay, so you can simply just go ahead and check that. Okay, now I will close it. Then since a single view has been created over here, but if you want to work on the multiple views, then you can simply create the multiple views. Okay, so whatever is present over there, you can simply just use it. Like if you want to work on the tile horizontal or tile vertical views, then you can simply work on these things also, and from here you will have a clear idea of how to select the nodes. Like this beam is selected, this node is selected, whatever you want to select, you can simply select it from here, change your properties. So these are also the options, okay, that you can use. Then comes this table option, where whatever the there is the whatever the things you want to see, you can simply see it from here. I haven't assigned many properties, so this like will not be very much useful for you. Then comes the 3D rendering. Since I haven't used any kind of property, so 3D rendering is not very much available over here. Okay, now let's come back. If you want to switch back to this option, just instead from the geometry, just switch back to whatever any other property section, and it will open up everything for you in the default manner. Okay, so basically these view options are useful whenever we have to make some changes. Then comes the specifications. So specification is something that I will tell you when we have to start working, okay, on these specifications. Like we have to check, like while working the while studying the IS 1893, that means the code for the seismic load, I told you that we need to add some reduction factors. So these can be added from here. If you want to add some beta angle, like you want to rotate some column, then you can use your beta angles. Okay, however I prefer like changing the property. That is much convenient for me rather than doing all these things. Now now for the supports. So here we insert the footings, then comes the loading, analysis, and design. Okay, so we will come to everything one by one. Let's say we have completed our geometry option, then we have to go for the properties. So here I have to assign some properties, or if you want to define some properties, then you can also define those properties. Okay, like over here, I will click on define, then go for the rectangle, and suppose I want to keep my column as 10 by 10 inches column. So I will go for 250 by 250. So press tab, 0.25, click on add, and here you will get the option of 250 by 250 column. Then comes this one where you want to add a beam. Let's say I'm going to add a beam of 250 by 300. So here YD is the depth, so I will just go for 250 by 300. Then comes the option of let's say I'm just going with 250 by 250 for plinth beam. Okay, so I can go for that one also. So you can see, since I have changed my unit to the metric, so it is giving me metric units over here. So it is showing me the sections in mm. Okay, now if you want to define, so rectangle has been defined. I think these sections will be enough. In case it fails somewhere, we can simply change it. Okay, then comes section database, values, thickness. Yeah, thickness is something that we may need if you want to model slabs in your model. So thickness is something that you can use. Section profile tables, this is, you can close this one. Let's click on thickness, and you can see suppose I want to make 125 mm or 113 meters, then I can simply just go for slab thickness of this one. Or if you want to go for 100 mm thick slab, so we can also go for 100 mm over here. And to write the 100 mm in meters, we are dividing it from 1000, so it is coming it as 0.1 meter. Okay, so I will simply change it as 0.1 meter. Now I haven't modeled any kind of plate over here, so what I will do, I will simply go to the geometry, then I will go for the view option, and here I will go for the front view. I will select these things over here. Okay, or you can simply just delete all this. Okay, that is a faster way of doing things. So I'm simply deleting everything up from here. Now I will select this one, click on selected objects, and go to the top view, and you can see only the selected objects are visible over here. So go to the geometry, add plate, and I will start adding the plate from here. So for adding the plate, even if I'll just add a large square or rectangle in this one, that will act as a plate. But whenever we have to do it specifically, then we can simply do it like this. Okay, now this plate is not added properly, I guess. I will check it once. But for now, I have to add the plates. So I can also use the translational repeat option over here if we need. But that I will use in the y-axis, that is the vertical axis, so that we can have a clear idea of doing things. Okay. So here we have our plates. Now, if you want to check it into the 3D view, you can go for the 3D rendering, and you can see that our plates are clearly added. Okay. Now, I will tell you a few more things. Like if you want to just go for Ctrl+4, then it will also Ctrl+4 is also the shortcut for opening it the 3D view of this one. Okay, if you want to check the isometric view, you can check it from here. Now I will simply go for selection cursor of plate cursor. So all the plates are clearly selected in a proper manner. Okay, I thought that this is not selected properly, but now I can see that this is selected properly. Okay, now what I will do, I will simply click over here. Okay, display whole structure. The whole structure is being displayed over here. Now what I will do, I will simply, yeah, so I think this is the time where we need to enter the properties. So what I will do, I will simply select all this and then select this, assign to selected views. Okay, So this property is assigned over here to this particular layer. Then I will select this, go to the front view, select all the beams over here, and then I will assign it to the selected beams. Okay. Then comes the selection of the vertical axes, vertical beams. So in software we call it beams. However, the vertical members are column in the practical life, but software calls it beam. So that's why I'm calling it beam over here. But it is basically the column. Now, for the selection, we can come to the selection. If you want to switch the cursor, then you can simply select right click and come to the select cursor, and then you can choose cursors from here, or you can come to the select over here, and from here you can choose the cursor, like a node cursor I have selected, and you can see whatever is there in the nodes that is getting selected. Beam cursors, so it will help you to select the beams, and then the plate cursors, it will help you to select the plates. Now since the plate is selected, I will simply like come to this one, and I will assign it to the selected plates. Okay, so this property has to be assigned to the selected plates. I have assigned it over here. Now you can say even this plates are the properties like this. Okay, now comes the columns. The columns are the only thing that are left over here. So what I will do, I will simply click on, go on to the beam section, go for the parallel to Y, and you can see all my columns are selected over here because the Y is the vertical axis, and I have selected every beam that is parallel to Y. Now I will switch to the property, this one. Okay, this property has been assigned over here, so this is the property for the column. So I will just go ahead and select the beams parallel to Y, and then I will assign this property to all my columns. Okay, I think this is clear. So if you will just follow every step that I am explaining over here in the proper manner, then you will find that it is very easy to work in the STAAD Pro. So I am explaining everything in as detail as possible. One moment, guys. But still, if you have any kind of question, you can simply ask me. Okay. So I think modeling part is kind of completed. Okay, but still, if there is something, then we will work on that one. Okay, so in the selection, okay, so this is the geometry cursor, member cursor, then this is a plate cursor. Okay, so we do not need to learn everything from here. We just need to understand the beams and the plates and nodes. So we do not need usually. Okay, so we can skip that one. Now over here, I have selected this one. I will check what is selected by going to the isometric view in the view section. Then I will go for the translational repeat, and that is over here. So go on the translational repeat, go on the y-axis, keep the spacing as 3, which is the building height that I have provided, and I will make ground 1 2 3 3. So I will go for the 3 repetitions over here. I do not want to click the link stress because I have already created the properties over here. Now since I have assigned the properties, so I can check this option, geometries and properties only, or I can go for the all options. So in this case, I will go for geometry and properties only and click on OK, and you can see all the properties are assigned over here. Now I will simply go to the plate cursor, select the plates, then I will go for the translational repeat. In the same manner, I will provide the same height, that is 3, and same numbers, that is 3, as the beam. Okay, same as the beam. Now click on OK, and you can see now I have plates all over here. So control plus 4 is the option of 3D view, or you can go to the view and go for the 3D rendering, and it will give you the rendered view. Now you can see since I have assigned the properties, so it is not looking like a frame, it is coming up like a proper model over here. Okay, now there is another thing that you can see over here. Like if you are pressing control, let's go to the geometry, so that in the properties you will have all the numbers which may look a little clumsy. So to go to geometry, and then press Ctrl plus 1 for this wireframe structure, Ctrl plus 2 for this view, and Ctrl plus 3 for this view. Okay, so Ctrl plus 3 is something that I basically use, or you can say I use a lot. Okay, Oh, I hope everything is clear. Now, if you want to make the rotations, use your arrow keys and you can easily rotate things like this. Okay, so you can see I am rotating all this. Okay, now what we have to go next. So you can see the modeling is done, the properties has been assigned, materials are already assigned, everything is concrete over here, but still if you want to check the material, click on the materials and it will show you what is the material that has been used over here. Okay, so everything is concrete. Specifications, I will not go for the specification of this project, but yeah, whenever we are going for the dynamic loading, then or you can say we are working in a live project that is in zone 4 or 5, then we will go for this specification also. And next come the supports. So here we have to generate the support. So normally our buildings is in fixed support, so we have to create a support. So click on the create and then go for the fixed, click on add and then select the supports, go for view, front view, and you can see whenever we are clicking on the supports, all this is highlighted. Okay, now go to the isometric view and you can see all my column bottoms are highlighted and I can assign the support to all these bottoms and something will like this will come out. Okay, now comes the okay, so support is done. Now comes the loading analysis and design. So what do you think? If you can take it, then I will just complete the whole thing because this is the basic modeling and not very complex things are assigned over here. So I will just give you a glimpse of the loading and other parts also. Okay, that will not be very tough to go. So let's go to the loading. Okay, so in the loading we have the first thing, that is the seismic definition. So click on the seismic definition and click on add. From here we have to select which code we have to use. So basically which code is there for the Indian. So this is basically IS 1893 part 1 2016. So earlier it was there in the 1893, then after that it was in 1984, then after that it was revised in 2005, then 2015, and finally it is 2005, and then it was in 2016. So in 2016 it has been split to 4 parts. So we have to go for IS 1893 part 1. Part 1 is for buildings. So part 1 and the revised version of 2016. I told you that the everything is inbuilt in the software, but we need to understand from where the software is getting all those values. So I am clicking on this one. You have to remember that whenever we are defining the seismic parameters, so we have to go for IS 1893 part 1 2016, and from here we can generate it. Suppose we have the option of like zones first. Okay, so one thing is zone, whether it belongs to zone 2, 3, 4 or 5, or it is belonging to some particular city. Okay, so whatever is there you can simply use it. In the city option you may or may not find your city, because you can see I have already shown you in the code that the cities are mentioned over there. So that is a possibility that you may find that city. It is a possibility that you may not find that city. Okay, so I am basically working in the least zone now. So let's work for the zone 2. Okay, so which is having the least factor of 0.1. Zone 3 is having the factor of 0.16. Then zone 4 is having the Z factor of 0.24, and then zone 5 is of 0.36. Okay, so let's work with the minimum 0.1. Okay, after that we have this option of response reduction factor. So in the response reduction factor, we have to choose what kind of the building we are dealing with. I've already explained you what is the response reduction factor if I was studying the code. Now here I will tell you what we have to choose. So basically you have to go for RC buildings with a special moment resisting frames. Okay, or if you have RC structural walls and everything is there, so you have already learned all the definitions of everything in the code. Okay, so if you haven't understood it, just try to watch it once, or not even if you are not comfortable with watching such long videos, then you can simply just go ahead and read out the code. So try to read the code as much as possible so that you can have a clear concept of how we have to do the selections according to our buildings in the software. Okay, then the importance factor, I told you there are three basic categories: all other buildings, important buildings, and then we have the residential or commercial buildings. So residential or commercial buildings with 200 or more occupants, they have the importance factor as 1.2. I am just going for all other buildings over here, which is having the importance factor of 1. Okay, now so over here, let's get to it. Generate. So we will go for RC buildings with a special moment resisting factor, a special moment resisting frame. So this will give you the response reduction factor as 5 over here. If you go for the ordinary moment resisting frame, then it is giving you the importance factor of response reduction factor of 3. For the RC structural walls, this will be 4. For buildings with ordinary RC structural walls, it will be 3. So basically we have to go for RC buildings with special moment resisting walls. Then we have the different soil types. The soft soil, medium soil, and hard soil is there. I've also explained these things in the code. Let's say our soil is medium soil, not hard, not soft. Then the structure type is RC moment resisting frame. So we have to go for that only. Okay, RC moment resisting frame. Damping ratio is 5%. That is there in the code. If you want to mention the foundation depth, you can simply mention it. Foundation depth over here is 1.5. Then if you want to go for the periods in X direction and Z direction, then you can also go for that. But right now I will not go into that complexity because that is something that you will need when you going for the dynamic analysis. So I will just start with this data and click on generate, and you can see all the data has been modified according to our requirement. If this generate option is not working in your software, because in the STAAD Pro Select Series 6 earlier this generate option was not there. So what we used to do, we used to open the codes and write all the values from the codes over here and then click on add. Okay, now the wall area, wall alongside Z direction and everything, that we are not doing anything over here. So I will simply click it. Okay, now since I have defined this seismic load, okay, that has been defined, the seismic definition has been defined, so I can just go with the load case details. In the load case details, we have to go for the primary loads first. So first of all, we need to add the dead load, for which I will add the username as the DL, dead load. Then click on OK. Then what we need live load, LL. Then there are other bunch of options which you can use if needed, like the wind load is there, seismic H, seismic V, snow load, fluid load, soil. So all other loads are also present over here, but I need to define only the dead load, live load, and seismic load. So seismic load in the H, that means the horizontal direction, and seismic load V, that means seismic load in the vertical direction, is added over here. Like in my previous videos, when I was using the another software, there you will find that I have used SLX, SLZ as my requirement. Right now, I'm using this as H, seismic H, that means seismic horizontal and seismic vertical. Okay, so this one will also be seismic horizontal one. Okay, not the vertical. So I will simply, whenever I have to change, I will simply double click on this, and then I can simply change it, and then click on modified, and the loads will be changed. Now in the dead load, what kind of loads we may have in the building? So in the dead load, first load is self weight, that will be acting in the vertical direction with a factor of -1, so that has to be added. Then the other member can be member load, which is the basically the wall load. So let's say I'm going for a wall load of -8 kilonewton per meter square. Why -8 kilonewton per meter? Why 8? Because this is, I guess, the load for 5 inches wall for a building height of 10 feet or 10 feet 6 inch. So I'm just going for that. Now I will add this load. For the parapet wall, I will add it as -2. Why minus? Because this minus is showing that the load is acting in the downward direction. Okay. Then there is area load, floor load, and plate wind load if needed. Then you can also go for the wind load. I have already done it for one project, but not in this project, not in obviously in dummy model. I'm not going to use that. Yeah, floor load we can use. So basically floor load, I will keep it as a -2 kilonewton per meter square. That is our or you can see I do not need to use the floor load in this particular case, because there will be no dead load over here. Everything I will consider as the live load. Okay, so I have considered the wall load, I have considered the self weight. Floor load is needed to be considered in the dead load when you are not modeling the slabs. If you are modeling the slabs like I have done here, then you do not need to model the floor load. If you want to model the floor load, then what you can do, you can simply go ahead and calculate how much load your slab will insert on your beams, and according to that you can calculate it per unit area, like in kilonewton per meter square, and then you can simply apply the floor load. Since I have already modeled the slab, I do not need to add the floor load, so I will simply go to the live load. In the live load, we have to just add the floor load, and here we need to add the floor load. Now for the range. So in the range, you can see this is 3, 6, 12, 18. So all the floors will have the floor load except the plinth floor, because there is no reinforcement over there and the load is directly getting transferred to the ground from the PCC itself. So it is not exerting its load on the beams. So we are not providing any kind of floor load over here. So what we will do, we will start our wide range from, let's say, 2.5, and it is 3, 6, 12, and 18. So let's make it for 18.5. Now there are some cases where we also define our X-range and jet range, how to do all these things that I will explain you while working on the live model. Not in this one, but you must be knowing that these values are also important and we do define these loads. Okay, now here you have to go for the direction of global X. In case you have like switched the axis to vertical axis as Z axis, then you will have to go for global Z. Otherwise you can keep it as global Y. Okay, now click on add, and you can see the floor load has been added over here. Now you can see if I'm just clicking on the floor load, it is clearly showing me the floor loads. If I want to assign the self weight, I will simply assign it to the view. So click on the self weight, then click on assign to view and click on assign. It will ask me whether you want to proceed or not. So I will want to proceed, and you can see everything is having the self weight now. Okay, self weight is present in the columns, beams, and even in the slabs. Now for this load. Okay, so this I have to assign individually. So what I will do, I will go to geometry, or go to the view, go for this one. I can select all the beams from here. Okay, now go to the isometric view, and you can see all my beams are selected. Okay, now I will go to the properties, the loading option, expand the load, expand dead load. Let's say I am assigning this load to all the selected beams. Okay, assign to the selected beams, and then click on assign. So it has been assigned to all the beams that I have over here. Now, if I want to, this is one way of doing thing. The another way, what is the another way of doing thing? Let's say I want to assign this one. So I can just click on use the cursor to assign. I can press and hold the control key. Then I can select my boundary walls, because this is a load that has to be added on the boundary walls only. Now I will just check whether it has been assigned to any other beam or not. So it has been assigned to few more beams. Okay, so this thing may cause some error. So what I will do, I will go to the view. I will just pick all this, go on the selected objects, go to the top view, select this, and then I will select my desired beams. I've already explained you how I am selecting the beams precisely. Okay, now click on assign to selected beams and click on assign. Keep in mind that you have to press the control button while doing all these things. Now I will go for the display whole structure, and you can see the load has been assigned properly. Okay, so whenever we click on any particular load, so it will be highlighted in blue color, and the rest of the loads will be highlighted in green color. Okay, so if I'm clicking on this, the 8 kilonewton load is highlighted in blue color, and 2 kilonewton per meter of the load is highlighted in green color. So this is how it works. So in the dead load I have assigned everything. Okay, the self weight is there, the wall load is there, and in the live load we have assigned the floor load, okay, which is clearly assigned over here. Now the load is assigned. Now we have to save it. So keep saving your model so that you do not lose your work. That is the motivation. Now if I want to go for the next step, so where I have to go, I have to go for the utilities, and there we have to open the command file. Okay, so in the command file, what we have to do, we have to make some changes, because we have to work on the seismic loads and all. So what I will do over here, load 3 and 4. Okay, so here I have not assigned everything in a sequence, so I will assign it load type 1, load type 3 and 4. Okay, there is one mistake that we have done. So first of all, we have to assign the seismic load. After that, we have to assign the dead load and live load. Okay, so here how you can change it, there are two ways of changing it. Either you can delete everything from here and you can change the sequence from here, or you can start using your STAAD editor, STAAD Pro Connect Edition editor. Okay, and what I'm going to do over here, I will simply show you. So I will just select this, Control X, then Control V. Here I will rename it as load 1. This I will rename it as load 2. Dead load I will rename it as load 3. Live load I will rename it as load 4. Okay, so this should be the sequence. First we have to go for seismic load in X direction, seismic load in Z direction. Okay, then we have to go ahead and assign this things. Okay, so backspace, Control S, save this one. Okay, now close this one, and it will open up our model in the redefined way. So you can see this thing is coming as sequence like this. So the name has not been changed, but the sequence has been changed. Over here we have to like name it. So I will rename it as SLX. That means seismic load in SLX X direction, and there I will rename it as SLZ, seismic load in Z direction. Okay, here I will add the load. I will have to go for seismic loads, and in the X direction I will go for a factor of 1. In the advanced models we also go for 1 and -1 both, but right now this one is enough, because in the load combination it always takes the plus minus thing, so we do not have to worry about that. So now this thing is clear, and you can see we have everything in sequence. Now if I'll go to the command file, so you will see the names has been changed. So either you make changes over here, it will be reflected over here, or you can make the changes from here and it will be reflected automatically over here. So you can see our load 1 is seismic SH and the title is SLX, then SLZ is there, DL and LL. Okay, so I could have made the changes from here also. Okay, that is not an issue, but I had to assign the loads, so I am assigning it like this. Now we will go for the next thing, that we have to assign the loads, okay, beneath this. That means the definition of the 1893 2016 load. So we have to assign loads over here. So how I'll do that? For that I will simply copy all the loads. Okay, so let's say I'm copying it from here and I'm pasting it here. So there is another way of doing things also. We can also go ahead and define the loads over there. That is another way of doing things, but this is easier. Copy it. So whatever is comfortable with you, you can just go ahead and do it. Control V. Okay, now in the seismic thing, it doesn't understand the term load, so we have to write it as like self weight is there, then we have to go for member weight. Okay, then floor weight. Okay, so this have to change just under the definition of IS 1893 loads. Okay, so this you have to do till here. Okay, after that in the load type and everything, you can simply keep it as the default one. You do not have to change that. Now over here, another thing that we have to go for, in the self weight we just need to enter the value. We do not need to answer enter the negative or positive sign. We do not need to mention the directions. So I am just deleting the directions. Basically we are deleting the directions, like this is global Y. I do not need to assign it for the global Y. I do not need to show that it is acting in the downward direction. Okay, so I am removing the direction. So global Y is the direction, negative sign means negative direction, that means acting downward. We do not need these things, so we will simply remove it from here. Now over here, if you are working for like I have already shown in the where in the study of the codes, we have seen that okay, we do not we consider the dead load completely in the seismic load, but we do not consider the complete live load. We consider only the fraction of that. So if live load is less than or equal to 3 kilonewton per meter square, then we consider only the 25% of that particular load. So here we have considered our live load as 2 kilonewton per meter square. So basically that 25% of that is 0.5. So I will write it as 0.5. Then I will press Ctrl S and it will be saved. Okay. So you can see in the definition itself, we have defined the self weight, the member weight, and then the floor weight. So we can also define it from here. Like I can click over here and I can click on add. Okay, so these things can be done from here also if it is not showing right now, but I prefer this method of doing the changes in the STAAD editor. Earlier the calculator was not highlighted, so I will show you over here, like 25% of 2, and that means 0.25 into 2, that is coming to 0.5. That's why I made 0.5 for the live load consideration in the seismic definition. Okay, so I think this much part is clear. Now we will go for the analysis. So in the analysis, we have the option of analysis command. So click on the analysis command, go for the no print option and click on add. This is mandatory, otherwise your function will not work. Then comes the design part. In the design part, what we have to design? We have to design for the concrete. So, and I have already made the changes in my software, so it is giving me automatically the IS 456. If you will not make the change like that over here, then what will happen? You will have to just click over here and then look for IS 456. Okay, so there are two ways. If you have not configured your software like I have shown you in the first few minutes, then you can just go ahead and choose your code from here. Just make sure that you are on concrete. By default, you will be on steel, but you have to switch to the concrete and there you will have your code. Okay, now here is the first option of select parameters. So just it will show you all the parameters that are mentioned in the IS 456. You have to just bring back everything from here. Then whatever your desired parameters, you can simply select it from here, like your clear. Okay, clear cover is there. Then what you need to know, ENSH is something that we use in our live projects. Okay, but right now we do not need that. So I will tell you where to use ENSH whenever it is needed. Okay, for now we need our compressive strength, yield strength of the main reinforcement, secondary reinforcement, maximum main reinforcement, maximum secondary reinforcement, and then minimum main reinforcement and minimum secondary reinforcement. So 1, 2, 3, 4, 5, 6, 7, 8. These 8 parameters we have to consider. So I will simply click on OK from here. Then we also need some commands. So like design beam, we need to add. Design column, we need to add. Design slab and elements, since we have already modeled the slab, so we have to add that also. Then takeoff, we have to add. Okay, close. Now we have to go for define parameters. Okay, since we have not defined the parameters are not visible over here. So I will simply delete these parameters first. Delete command. Okay, delete these commands. We have to define since we have selected the parameters, we need to define the parameters also. Okay, so define parameters. Clear cover for the beams, I need 30 mm of the clear cover. For the columns, I need 40 mm of the clear cover. Compressive strength of this will be, let's say I am going for M20 grade of concrete, so 20,000. Okay. Yeah, one more thing we skipped. We have not 1, 2, 3, 4, 5. We have not considered the load combinations yet. So I will tell you the reason for that also. Let me define these factors. So for FE500, the yield strength is 500,000 kilonewton per meter square. Okay. Then maximum main, let's say we are going for maximum of 16 mm dia bars. This is a small model, we can just go with the 16 mm. Then the maximum secondary, that we can go for 12 mm. Minimum main, that we have to go for 12 mm, because in the columns we have to provide the minimum reinforcement of 12 mm. Then the minimum secondary, we can go for the 8 mm. Okay, now from here we can add our commands. Okay, so it's not mandatory that you add it now. You can do it even after defining things. Okay, now here I have to add, like assign it to all the beams. So how am I going to do that? I will go to the select. There I have to go for the beams parallel to x-axis and beams parallel to z-axis, because this is my horizontal plane, and then I will click to assign to selected beams. Then for the clear cover of 40 mm, I need to choose my columns. So for that I will go for the beams parallel to y-axis, and here I will just assign to the selected beams. Then This is something M20 grade of the concrete I am using, so that has to be assigned to the whole thing that is present over here. So I will simply click on assign to view. Same goes with FY main steel grade and secondary steel grade. Okay, then same goes for the reinforcement also. So if you want to like provide 10 dia bars in the beams also, then you can define two sections over here: minimum main bar and minimum main bar of 12 dia and minimum main bar of 10 dia. These two you can assign, define, and after that you can assign it accordingly. But right now, since it is a basic model, so I will go with like this. Now you can see we have to choose for the beams parallel to y-axis, and then I can design the columns assigned to selected beams, and it will then the elements. Okay, in the elements I can assign to view. I think design beam is not present over here. I need to assign this one also, design beam. Close. Design beam. Now we have to select the beams. So beam, in the beam section, we have to go for beams parallel to X and beams parallel to Z. Now I will assign this to beams. Okay, so design of beams is also important. Now I'll go to the utilities and bring the beam to the top, because beam should be at the top, right? So I will just cut it and paste it over here, make a backspace, save it, close it. Now we will have to wait for a while. Now we will go back to the analysis, and there we have the option of run analysis. Okay, so even if you want, then you can perform the analysis after this one also. That is not an issue. But even if you, let's say analysis, then no print, click on add. There are only 2 times to perform analysis. You do not have to make the multiple times perform analysis thing. However, if you are getting some warnings for the warning, there is one warning. Let's see what warning is this. If this UBC analysis has been tension in the our computation. Okay, so for that, to remove this kind of warning, what we have to do, we have to go to our utilities command file. Okay, then go to load type 1. This is our seismic load. So here what we have to just write, we have to write perform analysis, and then we have to write change. Same we have to write over here in load type 2, that is SLZ, perform analysis, and then change. Okay, that's all. Save it, close it. So this is one way of removing the warning. Okay, so for different warnings we have different ways of doing things. So now we will go for the analysis and design, and then run analysis, and we will see whether we are having any kind of error or warnings or not. So if you are having some errors, then that is a strong no. If you are having some warning, then you can go ahead with the design, but the design may not be that much economical. So if you will just remove the warnings, then you will have your economical design. So I will click over here, concrete design, and this is passing at the bar sizes of 12, that means 12 dia of 4 bars. This will be good enough to pass. Okay, now one thing I haven't done yet. Okay, so in the load case analysis, load case details, we have defined SLX, SLZ, DL, LL, but we haven't defined the load combination. So I will go for the auto load combination. I will select the load combination from here, because in the practical life we have to go for the load combinations also. And if you are working on RCDC if you are planning to work on the RCDC after this STAAD Pro, then what you have to do, you can simply just skip this portion where we have to generate the load combination, and you can simply just generate the combinations from the RCDC itself. That is not an issue. But even if you are doing it over here, that is fine. So since we are not using the RCDC right now, so I will go for the generation of the load combination. And I have already shown you that our column is passing at 4 bars of 12 mm dia. Okay. Now we will see what will happen after the load combination. Okay. So let's add the load combination. It has already automatically taken that it is considering the IS 456 2000 table number 18. Okay. So it has already taken that. So this is starting the load combination with the combination number 5, since we have already 4 loads 1 2 3 4. So it will start from combination number 5. You can also go ahead and define the combinations from here. Okay, that is another way of doing things, but that is very time consuming, so I do not prefer that. Just go for the auto load combination and then click on add. First of all, generate load and then click on add, and you can see all the load combinations are present over here. Okay, so now you have 20 loads, like 4 major loads, and then the rest are load combinations. Okay, so whatever was there in the code, I have already explained you. You can see over here all the combination is coming in detail, like this is 1.5 into load 3, then 1.5 into load 4. Okay, then 1.2 into load 3 and 1.2 into load 4. So dead load, live load, everything is getting assigned over here in the proper manner. Okay, so you can just go ahead and check it. If you want to add some more complex loads, you are free to go do that. Now I am going to the analysis. I have told you that how to do it. Okay, still if you have any kind of question, you can simply ask that in the WhatsApp. If you want like how to generate the loads manually, then you can also ask that, but if you are going for the automatic load combination, that is enough. Now you can see we have 0 errors and 0 warnings, 4 nodes, so that is good for us. Now let's check how this has changed the reinforcement. Now earlier it was 12 mm dia bars, and there are 4 in numbers. That means 4 bars of 12 mm dia. Now after applying the load combination, that means the loads have been increased on the model. So earlier individually the loads were acting. Now the combination of loads are acting. So we need to strengthen our beams and columns, and that's how. I haven't changed the size, so obviously it will increase the reinforcement. So now we have to provide 4 bars of 16 mm die. Okay, so that's how we have to do it. Okay, so the ST required was 554. Now what we have provided is 1287. Okay, so these are the things. FY is 500, FC is 20 MPa. Okay, FY 500 MPa. Then the design load was 12, location, and then PU, which is loads in KNS, and then MZ and MY is also provided over here. So you can just if you want to check the deflections, what will the deflections that you have that you must have studied in your college days, that is shown over here. The shear bending. Okay, shear bending is clearly shown. What is the FY, what is the MZ, what is the distance, at what distance, what is the particular load or the bending, that is shown over here. Okay, the properties, everything is clearly defined over here. So this is in the same way you can check it for the beams also. So beams, you can see 3 bars of 12 mm dia on the top, 3 bars of 12 mm dia at the bottom. Everything we have the same thing. Now let's check for this. Here we have the concrete design of 312. On this side we have to provide 412 and 316, 312 at the bottom. So how to do all these things, that I will explain you one in the live project while we are doing the detailings of how to modify the results and everything. But for now, this is your result. Okay, and you can design anything in STAAD Pro in the same manner that I have designed right now. And if you have any kind of question, you already have my numbers, just go ahead and dial it. I will definitely answer all your queries. If you do not have any kind of question, then you can simply share this course with your friends so that they can also be benefited from this. See you guys in the next session. Till then, keep learning. Thank you.